5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
Hey, space enthusiasts. So India's space sector is really blasting off. Yeah, that was a cheap pun. But among other things, as you're probably well aware, India just became only the fourth country to soft land on the moon. So it makes sense that we'll have more Indian space companies and space people as guests on this podcast. Our first one is Tushar Jadhav. He's the founder and CEO of Manastu Space, a propulsion startup from Mumbai that recently announced a $3 million financing round. Please enjoy hearing about Manastu and space in India in general.
My name is Raphael, and I'm an investor and advisor to space companies. Just as a reminder, this podcast is for informational purposes only, and nothing should be taken as investment advice. This podcast is sponsored by Nano Avionics, a satellite manufacturer and mission integrator. Their technologies enable many space companies worldwide to offer services that improve life right here on Earth, such as providing global connectivity, conducting Earth observation, or contributing to scientific discoveries. Check them out, and also check out my episode with the CEO and co-founder. Sadly, I am not a rocket scientist, but I'm an alumnus of the International Space University. ISU offers a number of educational programs about space worldwide. Check them out at isunet.edu. And just some final things before we start the episode about ourselves. If you enjoy the podcast, please leave us a 5-star rating on your favorite podcast platforms such as Apple or Spotify. If you want us help expand our work, you can do so and support us at www.patreon.com/Space Business Podcast, and we'll also put that link in the episode notes. And lastly, you can follow us on Twitter at podcast_space.
Hey, space enthusiasts. We're back from our summer break. It's time for new episodes of the Space Business Podcast, and we have a super timely episode. I'm sure many, if not most of our listeners may have been watching the Indian Chandrayaan-3 mission to the moon. It's obviously a successful soft landing on the moon. And I think that has really brought home the point to anybody who wasn't aware yet that India is, I was going to say a rising space power, but frankly, it's an existing space power. It's just really illustrated this point very, very strongly. And speaking, wearing my venture capital hand for a moment, I think there's just so much more in terms of exciting things in space to come out of India. So in this vein, very happy to have a prominent Indian space startup on the podcast today, Manastu Space, represented by their co-founder and CEO, Tushar Jadhav. Welcome, Tushar.
Thank you, Raphael. Thank you so much. Thank you for having me.
And so why don't we start as we always start when we have a startup on. Tushar, do you mind giving us the elevator pitch on Manastu, please?
We're building green propulsion system for satellites to replace old, toxic, to be replaceable hydrazine-based propulsion system and making it more efficient, cost-effective, and also adding more functionalities on top of that maybe you can add intelligence and to the debris collision avoidance and the services on top of that. So currently focusing on green propulsion system, which is around 30% more efficient, 50% more affordable, and around as much as 3 times safe in terms of toxicity levels. So that's what currently we are focusing on.
And so let's expand a little bit on this word green. Because obviously that sort of brings in a sustainability angle, which is also sort of obviously a big theme in all industries worldwide. What precisely makes it green? And since we're like a non-technical podcast, maybe you can just expand for a couple of minutes, sort of like why satellite propulsion currently isn't green.
So let me explain first what the propulsion system is and what is the need of it. Mm-hmm. You can imagine propulsion system is like what steering wheel and engine is for your car. Same, the propulsion system is for the satellite. So you use steering wheel and engine to move when you want to move from one side to another side, to go from one destination to another destination, to avoid the incoming traffic. Exactly the same is the role of a propulsion system in terms of function wise. To move a satellite from one particular location where the rocket leaves the satellite to the location where it is supposed to go, and then maneuver itself in a particular orientation and maintain that orientation so that antenna points towards Earth and your solar panel points toward the sun. So all these maneuvers, including now the problem of the debris is coming. Debris, you can imagine, is like you're on highway and there is a lot of traffic coming towards you, and if you see something coming directly towards you, you want to move. And that's the job of propulsion system, to actually move the satellite. So all those things are done using the propulsion system. For that, the satellites carries most of the satellite carry a dedicated fuel with the tank, and then the engines called thrusters around it, depending on the type of your propulsion system, and you control the thruster either autonomously or manually, depending on the requirement. So this is more or less what the role of propulsion system is. So now coming to the green point. So for last 60 years, 50 years, I will say at least, people have been using, all the space agencies and large satellites have been using something called as a hydrazine as a fuel for the satellite. We call it the propellant. This hydrazine is very toxic in terms of if the hydrazine falls on your hand, if you inhale the fumes of hydrazine, those are very toxic. The toxicity goes in the orders of, close to, say, cyanide. It is in that order of magnitude toxic. So what does that do to the people? So if you are someone who is handling, you are doing some development, or you are putting the fuel into the satellite, you can imagine this is a very, very big risk for the whoever is handling. And the fumes, if you are doing some development, the longer exposure, that gives you the cancer. Definitely that you don't want as a humanity aspect. The second aspect is the cost aspect. Imagine you have to carry 1 bottle of water, 1 liter of water versus say 1 liter of say cyanide. The cost will be very different. The mode will be very different. The way you will transport, the safety precautions, they will be very different, and that adds up to the cost. As the more and more industry is getting conscious about the cost, and that being one of the major separating factors between the different products, we believe that was that was a requirement from the industry. So because of the toxicity, a lot of European in Europe there is a program called a REACH program, under which they have blacklisted it, or they are under the watch list. This hydrazine is under watch list because of its toxicity nature, and for the businesses because it adds up into the cost. So there has been a demand, and there has been a search for something that is safe to handle, maybe a same performance or better performance in terms of specific impulse. Specific impulse is like what mileage is for a car. So specific impulse is for the satellites and satellite fuel, and something that is more cost affordable. So safe, efficient, and affordable fuel is called as a green fuel generally. That is a accepted widely definition of what is a green fuel for the satellite means. So just adding to then why now, and why not so many, why so many years they have been? Well, for a simple reason, people are well versed with how the system works. Okay, what are the components? What are the weighted parts? What will be the there is a catalyst material, how the engines will be, what will be the storage condition, how the fuel will behave under different temperature in different conditions. So people knew that well. That was very well established, and so there was no real push, because the governments were doing all the missions. And if you are government, your focus will be to get the mission successfully, rather than reducing the cost or reducing focusing on so much of sustainability. So when more and more commercialization started being a main center stage, taking more center stage, then that requirement started. And since 2010, 11, 12, the sustainability angle started playing a bigger role in terms of it getting banned in, or looking to be banned in Europe. So alternative, that became another driving factor. So that's why there is a quest for a new green, safe, efficient, affordable fuel, and then the system around it.
Okay, so why was with all of these disadvantages, why was hydrazine originally chosen? I mean, was it like it had, like, for example, really good energy density, or like, you tell me, and then whatever it was, which was the big advantage of hydrazine, I guess we can now start to replicate these advantages with other fuels. And why is that now possible?
Right. So in US in 60s, 70s, there were a lot of quest for finding the best possible propulsion system, basically effectively the fuel and then the rest of the system around it. And then hydrazine was one of the contenders. And then there was a lot of quest to find out there is a material called as a catalyst that sits inside the engines, these thrusters. And that becomes a secret ingredient that becomes a key to success of your propulsion system. the longer the life it can survive, the longer the mission life, more the fuel you can carry, and then it can last for say 5 years, 7 years easily. So that was one of the major factor, and the Shell came up with a very interesting design of a catalyst after multiple iterations, and that become a industry gold standard. And so everyone started looking using it, and that become parallelly, because now that become a one important standard, people start develop the remaining components like a tank, how to handle it, what to store into it, even though it was toxic and dangerous, but people created SOPs with that, safety protection with that. So and the cost was not a major constraint that time, so they were okay to take those risks. In return, they were because they had a system that was reliable. So that was being a major factors that gave rise to hydrazine in 70s 80s, and then it became a de facto choice going forward till 2000 2010 or so, and then they quest for an alternative after that.
And so what is your system now using, and how does it sort of compare to hydrazine?
Yeah. So when we started finding the alternative, and the one thing that was there was a hydrogen peroxide, which was used even before hydrazine came into the picture, and it was used in the V2 rockets, and even in some of the current Russian missions, Soyuz mission, the hydrogen peroxide is used to some extent is their gas generator. So hydrogen peroxide had some advantage, obviously, and some of the disadvantage. Advantage was it was easily available, that it was safe to handle in terms of toxicity. The disadvantage was it had a lower performance than hydrazine, and the science, the materials were not evolved, which can store the hydrogen peroxide reliably. That was a major challenge. So what we did is, and as this is the same hydrogen peroxide is what we use to clean our wound, and
it's an antiseptic.
Yeah, antiseptic. That speaks about that it is safe to handle because we already put it in our body to some extent. So we started with hydrogen peroxide, and which are safe to handle. Of course, you need to respect the hydrogen peroxide because of stabilities and all those things are. If you maintain the cleanliness, you follow the proper protocol. Hydrogen peroxide is good friend that way. So over the period of time, people established all this protocol, what material to use, what handling to use. So hydrogen peroxide started becoming a very interesting choice. And then, but still, its performance was low. So we added some additives into hydrogen peroxide to increase its performance and increase its life. With a higher performance of base being a hydrogen peroxide and with added additives to increase the life, we got sort of a best of the both worlds in terms of safety and the cost. Hydrogen peroxide is readily available, and in terms of higher efficiency due to our addition of additives into hydrogen peroxide. So this combination together is the first innovation that we started with, which is hydrogen peroxide based fuel, as we can call. The question is, what is the best? What is the advantage? Of course, first is the safety. It is as safe as water because we put it into the wound. Once you maintain the cleanliness, it is safe to handle. That is the first one. The major one is the performance and the cost. So the cost of the performance of system that we are building, we are targeting around 30 to 40%, at least 30% higher efficiency density ISP, we call it and as much as 50% lower cost of the whole system, because hydrogen peroxide we use, then we know the material that we need to use along with this hydrogen peroxide are also readily available. Then some of the polymers that are also available because the material has been well developed for last 50-60 years. So thanks to that, so the cost of overall system development goes down, and that adds up into the cost of one unit system that we will sell it to the customer. So safe, efficient, and affordable are the three major advantages with our propulsion system, with the hydrogen peroxide based propulsion system that we are developing.
And I guess, as you mentioned before, part of that cost advantage is probably that the handling is safe. You don't need like a whole lot of expensive safety protocols.
Exactly. So my team just currently works with the basic PPE kit as a safety goggle, the coat and the cap, and that should be good to go. But if you are handling hydrazine, you need to wear whole self-breathing suit similar to what similarly astronauts use, which has a self-breathing techniques and everything, and that adds up a cost. As you can imagine, and of course, transportation is another problem challenge with it.
And so if I remember, I mostly know hydrogen peroxide as in its household use as an antiseptic. One thing I seem to remember is that it's sort of unstable. It decomposes quickly, but maybe this is because it reacts with atmosphere and this is not an issue in space, or?
So hydrogen peroxide, first thing, the baseline is we need to respect hydrogen peroxide. So we cannot take it lightly. What do I mean? Why I say that way? So there are 2-3 factors that makes hydrogen peroxide unstable. You can say, imagine it's a person and it gets angry with some of the few things. That is, first is impurities. If impurities are not properly maintained, then that gets hydrogen peroxide get destabilizes and start decomposing. Second thing is your containers, the tanks, and the places where you are storing, that has to be properly made the surface suitable for hydrogen peroxide. That means you need to clean it properly. You need to have a smooth surface. So some of the processing needs to be done properly. So you need to have that done beforehand. Good thing is all the literatures and the processes are available for that, how to do those things. And then the third thing is in terms of you need to have some mechanism if things start going wrong, in terms of if start decomposing, you need to have some way to release that pressure. The pressure builds up, and so that you can contain that reaction. So preventive measures, that initial precaution that you need to take care, and if just in case something happen, you need to have an option to be safe. So with that, we believe, and even you saw a lot of NASA has been developing a lot more. They're investing very quite a big way in a hydrogen peroxide based system. Of course, in Europe, US has been developing, Russia has been developing hydrogen peroxide based system for quite some time.
And so one more question on hydrogen peroxide. So one other trend or topic, whatever you want to call it, in the space sector has been the potential of refueling satellites. And I think the jury on whether this is a really big market is still out, but let's leave that to one side for the moment. Is hydrogen peroxide, is it amenable to refueling as well? Like, would it be possible to store hydrogen peroxide in, let's say, refueling stations in orbit?
Absolutely. I mean, that's at Manastu, that's definitely a plan for next 10 years going forward. So we don't throw away our cars once they're used one time. So why to satellite? So that's the whole understanding behind it. And if you can refuel it, you can have a lot of mission flexibility. So that can you don't need to launch a completely fuel satellite. So that adds up a lot of avenues for the satellite people. They get a lot of mission flexibility. And the hydrogen peroxide and the work that we are doing is definitely on that line. Can we create a system where we give our propulsion system with hydrogen peroxide with it to the customer, and then have the option to refuel the same satellite afterwards with our, maybe a fuel station in space. Similarly, what Orbit Fab is doing, can we do that for our specific propellant? Because anyway, our propellant is already there in the satellite. So that's definitely been a major interesting development that is happening maybe for next 5 to 7 years in space.
And so just finishing up on the technology aspect. So probably a lot of our listeners are already aware that, generally speaking, about in-space propulsion, you can divide it into 2 big classes for the moment: chemical propulsion, but then also something called electric propulsion, which is used a lot, and where basically a gas is ionized. Well, usually a gas is ionized, and this is something, for example, that the SpaceX Starlink satellites are using as a propulsion system. Do you just very briefly want to compare the 2 approaches, electric and chemical propulsion, and sort of the relative advantages and disadvantages?
Yeah, of course. So definitely the electric propulsion becomes a very exciting field. We believe, and rather than competitor, I'll say both technologies needs to work hand in hand, depending on the mission and depending on pros and cons, or either both together sometimes, or maybe depending on the mission, you select one of them. So as the name suggests, electric propulsion, you have electricity. Using the electricity, you ionize the gas, and through magnetic field, you accelerate the ions through the changing electromagnetic field. You accelerate at very high velocity. So the good thing about electric is they get a very high, something called as ISP, specific impulse, like mileage I told. The challenge, so that means for a particular amount of fuel that you are carrying, the gases you are carrying, you can produce a larger impulse. That is the requirement of a satellite. The challenge with the electric propulsion is because you need it generates a very small thrust, and so because of the increasing debris problem as well as the solar wind related challenges, the Starlink lost a lot of satellites because they could not control when the solar wind was happening, because the thrust was not enough to counter the drag produced because of the solar wind. And of course, the time needed for particular maneuver from going from one orbit to another orbits are significantly higher, and the more time is lost opportunity. So exact as you can imagine, the opposites are the advantages. So the chemical, the efficiency is in terms of absolute numbers is lesser than electric. The advantages are you can generate 1 Newton, 10 Newton thrust at very short duration, very quickly, and for quite some longer duration. So depending on your requirement, and you can move the satellite very quickly. So another interesting area that we believe that that will shape the discussion between electric and the chemical, maybe the how the starship economic. The starship economy is a lot of, we have read a couple of places, the starship economy where the starship will be a major launching player, where the volume will not be a big constraint, even the weight will not be the bigger constraint. It will be your size of system, and the time will be a major selection factor. So we believe chemical propulsion with higher thrust, so that you save a lot of time, because their time becomes your major saving factor rather than weight. And even the volume, and with the options of refueling, you can achieve the best of the both worlds. So you save time, and also you get a lot of mission flexibility. So that's what we believe future will be going forward from chemical propulsion system wise.
Yeah, it sounds almost like the sort of the advantages of electric propulsion, the really high efficiency. It would make sense. Like when you started here today in our podcast, at some point in time, you went through how propulsion is used, and you said like, okay, to point the satellite in the right way, I guess what we sometimes call station keeping, right? And I guess because that's not super time sensitive necessarily, that's, I guess, electric propulsion could be very well used for that. But then every time one thinks of like a higher, some maneuver that requires a higher agility. And you mentioned kind of getting to your, changing orbits or getting to your operational orbit. And you mentioned Starship. And of course, if SpaceX is going to continue with Starship, what they're already doing now with Falcon 9, which is sort of these shared transporter missions where everybody's satellites get kicked out at the same place, and then you have to go to your final orbit. Then, like you said, you don't want to use time, and you want some form of agile propulsion, I guess, either on board your own satellite, or maybe you use a space tug. But in that case, the space tug needs the powerful propulsion like you. So yeah,
absolutely. You're bang on the point. Exactly the point. Yes.
So no, very interesting. And so let's talk about your product in a little bit more detail. So, for example, your first propulsion unit that's going to come onto the market, like what class of satellites is it targeting?
So immediately for next 12 months is what we are targeting is 2U class, 3U class propulsion system that will go into, say, 10U, 12U, or 20U class satellites. So we believe that is one market. So that will be partly to do the tech demonstration, and so that we have get some flight heritage to some of our critical technology. The point of B is when we are getting a lot of interest from the customers for that class of propulsion system. So 2U to 3U kind of propulsion system with 1 Newton thruster, basically of capacity of 1 Newton. And parallelly, we believe the another major market is definitely a satellites of 150 kg class, and little more than that. So that class, 150 kg class, anywhere between 100 kg to 250, 300 kg class satellite. So that is another class of satellite that we are targeting with 1 Newton thruster and the system around it. So initially 2U class system, and then around 150 kg class satellite propulsion system. That's what we are currently working on.
And your business model here is to sell those propulsion systems by the unit, or is there something else? Like we've seen for example, some propulsion providers come up now with sort of a per use type business models.
Yeah. So currently we are having as a product market rather than per use market. Going forward, we are exploring, can we have a per use market, especially if we can get the refueling done. Then that becomes the fuel also becomes another commodity that we can have as a service on top of that. So per use becomes a very interesting after that. So we are exploring all the options. So currently we are going with the propulsion system as a product market option.
And so for the people who pay per unit, because of the various advantages you have discussed, like using the green fuel that requires less handling, I assume you expect basically a price advantage compared to currently available systems.
Absolutely.
Okay. And when will those systems be available for order?
Hopefully you can order, but the development is maybe in next 12 months we'll do the first flight testing. So we should get a data in maybe after 2 to 3 months in the downtime. So after that we should be able to deliver some of the 2U class system, hoping that things goes right.
And this in-orbit demonstration, the flight test, this is going to be, do you already know, is this going to be, for example, on a customer satellite or some sort of hosted mission, or how will you do that?
We are figuring out if anyone we can partner with, we are definitely looking for this partner. Either the upper stages of launch vehicle as a platform, like what ISRO does some of the testing, versus someone who is some partner as well as, or we can book a slot also on one of if there's some satellite is in that targeted in that. So we are now exploring all the options, or some of the university missions who are proven satellite platforms, so we can target with them. We are exploring all the options right now, and if someone is open for collaboration, we are happy to do that.
And I guess your main customer group are the companies operating satellite constellations of the size classes you mentioned, or is there any other type of customer group that comes to mind?
Definitely those people, 15, 20 kg class, 12U, 16U, 20U kg satellite. Another is 100, 150 kg class satellite. Another class that we are seeing interesting development with is with a sample return mission kind of thing, where you go do some science experiments or some production and then bring the samples back, bring the material back. So they need a very good, precise control with a high thrust for their mission, because the mission life is generally 6 months, and they need a very controlled re-entry for that. So all the re-entry missions we are seeing a very interesting prospects with them.
And your propulsion units will be assembled in India?
Yes, absolutely.
And are there any considerations in terms of export controls, things like ITAR, or is it actually an advantage because you may not have to comply with as many export controls as some other countries?
ITAR generally we selling it more of a component, or we buying from US companies selling it to foreign countries. So we have seen that that is very strictly how they follow. The other way around are comparatively much relaxed option. That gives us the option that when we are selling it to the, say, Europe or Japan customer, then the regulatory issues are much clearer or much simpler in India. So we just need a couple of permissions from the ministries, and we are closely working with them already. So after that, we are able to sell it. So we see that as a slight advantage, if you can call.
Mm-hmm. Mm-hmm. Yeah. And so coming back to your sort of company timeline, so your current status, I guess, is you're developing the system for the first flight test. Is that fair to say?
Absolutely.
Okay. And then you conduct a flight test, you analyze the results, and then I guess if everything looks well, you're going to start looking to scale up and fulfill customer orders.
Absolutely. So we are already talking to the customer. So we'll keep them ready, and parallelly the development. And once the development is, at least the first flight demonstration is done, we start delivering to some other system. Parallelly, we'll invest more onto, say, 150 kg class propulsion systems also, and doing the flight demonstration for that system also. And of course, we'll set up some of the manufacturing depending on how the orders looks like, and how the order books looks like, and how the interest looks like.
Yes, and then you mentioned there may be eventually some add-on services or products like the refueling.
Yes.
Actually, on that, you've mentioned space debris and, of course, the importance of propulsion to space, to collision avoidance, I should say,
yes.
Whether that's with debris or even other objects a few times. Is that something you're looking to actively get involved in some way as well, beyond just the propulsion system?
Absolutely. We are already engaging with some of the companies in India, outside India, so our propulsion system, and then the intelligence about the debris, and then the probability of debris hitting, using the data from this data companies who are doing the space situational awareness. So their data and our propulsion system we can call as actuator, and that's complete flight collision avoidance system, what is there in the airplane, something can be done in the satellite is what we are currently exploring, and we are seeing a lot of interesting development. So we are working with a couple of people to do that. So that will be the next add-on version for this propulsion system.
So because right now, to my best knowledge, this whole process is basically completely manual, right?
Absolutely.
Like you said, there's some companies providing the data, and then if there's a risk of collision, somebody basically manually takes the decision and executes on moving out of the way or decides who should move out of the way. So if I understand it correctly, what you would be looking to do is sort of like work with some or more of these SSA companies, and even some in India, right? Like Diganta, I guess, as an example, and work together and put something that's integrated where maybe at the end it's like even fully autonomous.
Absolutely. That's exactly the plan to start with.
Okay. And so if you take all of this together, sort of like starting from propulsion system, and then different size classes, potential add-on services, in your and the co-founders' minds, like, I don't know, 10 years from now, what's your vision for the company? What would you like Manastu to be?
What Manastu to be like, solving the larger problems of the society in terms of making the space sustainable and creating a happy culture at our end in the company. So these are the two major goal that we are working with. So creating a culture in our company where people want to work, innovate, fail, and then succeed eventually, and for a greater good of ensuring the space remains sustainable, and that has actual benefits for the people. So that's how the story also of Manastu Space started. If we get a time, we can get into how the Manastu started, and that's why the roots are. So that's why we always look out for that option, those things.
That was literally my next question. I wanted to jump back to the very beginning and hear the origin story, like how you guys came up with this and why you originally wanted to do it.
Yeah. So story of Manastu started actually much before Manastu Space actually started. Me and my co-founder, we were a student in a university called IIT Bombay, and we were fresher first year in the college. And we saw that there was a team that was building a satellite. This was 2008 and 9, and space was not cool. It was just cool enough that, but not in the reach of people who what to do and what not to do. No one knows. So we said, this is something interesting. Then I dig deep and then joined the team. And then one thing another, I was a part of the team. So one of the application of the satellite, the payload of the satellite was to get the early warning of a tsunami. So how we are doing is we are studying some ionosphere in the atmosphere, and when the tsunami happens, you see a lot of fluctuation in the ionosphere. And if you have a satellite on top of that area, a constellation of such a satellite, you can get a early warning that tsunami is about to reach. There is to your shore, and you can get some 5 to 10 minutes early warning. And that 5 to 10 minutes early warning with a proper rescue plan can mean a saving of a life of maybe, if not few $100,000, definitely few hundreds of life for sure. So we're working with one of the universities from France near Paris, and we realized as a young mind I was very fascinated by that. So space, tsunami, saving the lives, and that was like, it was a eureka moment for me personally, that this is very interesting. And because internet was already a big, so she realized that it's a platform, like the space is a platform to solve the problems, and it has a real meaningful capabilities to solve the real meaningful problems. So that was our why. We do that to solve the problems using the space as a platform and ensuring that the space remains sustainable. Then fast forward to that 2016, after a lot of hard works of multiple years, multiple time project coming to close, and then again reviving, convincing ISRO to finally launch the satellite into the space. In 2016, we launched the satellite, and the day the satellite got launched, you can imagine it was the October Sky moment for us. If you've seen the movie October Sky, so what happened when they first time launched the rocket, so that was exactly the moment. We cried, we were like a baby, and I will not even trade that experience for say multi-million-dollar, because that's very invaluable personally for me and my whole team that time. So that day something changed. That day we realized this is a passion. We felt something complete. This is what we want to do the rest of the life. So this purpose of building space technologies to solve the problems on the Earth and ensuring that it remains sustainable so that the benefits reach the last person, and this passion of building space technology is something that is hard, but something that is so rewarding into the space. So this put together is when in 2017-18 we founded Manastu Space. So this passion married with the purpose is when the Manastu Space was born.
And so for probably specifically for our non-Indian listeners, what does the name actually mean? Does it name anything? Manastu?
Oh yes, yes, yes. Manastu is a Sanskrit. Sanskrit is the oldest language known for the mankind. It is in here we call it as a God's language. So it is called as a man means mind, and astu means fulfilling your wish. So fulfilling your wish in what a wish in your mind. So that's the Manastu's meaning.
Okay, very cool. And so you said just before that when you started out, space was not yet seen as cool. So now, 10 plus years on, or maybe I guess even almost 15 years on, space in India seems very cool, I guess. I mean, I've seen these sort of video clips from public places with screens when Chandrayaan was landing, and it looked like people were watching like a sports event or something. I mean, it was actually crazy good to see how people would get so excited about like a science mission. And so since space is cool now, can you talk a little bit more about sort of like since you're based in Mumbai, right?
Yeah.
Okay. Can you talk a little bit about sort of like your view of the current status of the Indian space ecosystem, like how it's evolving, how many other startups there are, like how the support both from government, local VC community, whatever, just like a general overview of the Indian space startup community in your view.
So this Chandrayaan landing was, what moon landing was for US, and it sparked a new whole generation with a new aspirations when humans landed on moon. So that's something similar of that order was the moment for Chandrayaan and for India. So it was, you can imagine you can imagine it was probably the bigger than any of the, as much as any of the, if not bigger than any of the sports big events like a cricket or football in any of the Western countries. So that whole ISRO's missions, and no, we have a very different, before I get into the whole ecosystem on the space and India, what is happening. So let me spend some time about the ISRO and the role of ISRO and the space. So for Indians, space it's very dear. I mean, more than any, I can't find any other word than being very dear to us, what ISRO has done. And, we associate India's growth, our own personal growth with ISRO's growth. I mean, when ISRO succeeds, the world country succeeds. And when ISRO cries, we cry. So that is, that is the relation that we have. And I believe it's very hard for you can have it your company, but having it with some of the government entity, that relation is, I think that is very rare. And thanks to the founding fathers of the Indian space, including Vikram Sarabhai, and then Abdul Kalam, who was the president, and then few more, many people who worked after that in ISRO. So thanks to those people, so we have that very, very close, intricate, and very dear relation, if we can say that way. And then Chandrayaan 1, then Mangal moon mission, Mars mission, and then failure of Chandrayaan 2, and then Chandrayaan T success. It was, you can see, as like a Hollywood movie with a very interesting climax being the Chandrayaan, and then successful landing being the successful climax of that movie. So that is exactly the case with what Chandrayaan could achieve with the Indian mindset. And mission was one part. I mean, the success and all those things. Well, one thing that was very happy for us personally was that people got excited. I mean, we got a lot of kids got excited and they started exploring and asking questions. Oh, what is there on moon? What can we do? Can I go? I have a niece of 3 years, and she is also already saying that, oh, when can I go to the moon? I want to go to moon. And that's, you never know. I mean, the dreams do come true, and this was the dreaming moment that has come true for a lot of Indians, and that is a future dreams for the next generation that will be coming up. So that did a lot more than just a science for the country. Science is still the exact results and will still come out slowly. We could found the sulfur and all those things, but a lot more things will come out as and when the time proceeds. But more than that, India got united, I can say. Our hopes, that was a very hope moment for us. even the G20 meeting and the whole prime minister was in BRICS, and we got a lot of geopolitical advantage or geopolitical soft points we could score in that BRICS summit in South Africa that time when the prime minister was there. So all in all, that has been a very, very interesting event and success Chandrayaan 3 had. Coming to the ecosystem in terms of the startup and funding, so government. So and for our personal experience, things were very tough till 2-3 years ago for any deep tech startup funding, let alone the space funding. Thankfully, with a lot of change, reforms at the government level, and initiatives by the ISRO and even the ministry, and whole transition towards sustainability, deep tech, and technology that has a hardware as a main product versus app-based systems, fintech, and then e-commerce, which was major highlight of the startup ecosystem in the last decade. That shifted to hardware and the more environment and the space and the healthcare related development in this last 2-3 years, this decade. So thanks to the policies, thanks to that policies leading up to the slowly changing the mindset of the investors. Angels came up initially, and then the early stage VCs. Now we are seeing the Series A, Series B stage VCs stepping up forward and then putting in more money into the startup, and then Indian startup being attracting the foreign money. That is another hallmark. So that has fueled the growth significantly. Third has been access to ISRO critical facilities. ISRO gave all the startups access to their facilities, their team, and their components with a very open arms. So that has significantly added into the development and the whole way the startup were looked at and the way the startups are now looked at currently. That has changed significantly for a simple reason, because startups can't set up all those facilities and they don't know how to do those things. So with the help of ISRO, that process has been very significantly expedited from ISRO side with the help of ISRO. And then therefore, definitely then because of all this ecosystem developing and thanks to publicity through the missions like this Chandrayaan, Aditya L1 mission, that is also very fascinating mission, and of course all the satellite and Gaganyaan mission, which is the human mission that is coming up in this year or around next year, early next year. We are getting a lot of talent who is interested to stay in India, do the space tech, aerospace engineering, build hard technologies, hardware, software. So that has fueled the talent part of it. So all these 4-5 factors are playing very, very nicely. So startups are now towards the stage that they need to start delivering. Startups who are at 4, 5, 6 years of establishment, like us, we are at the end now. We are about to start delivering results, and once we start delivering the results in terms of products, services, we can attract even more funding like Series B, 150 to 100 plus $1 million, Series C, D investment, and then that can take the ecosystem to whole new level. And hopefully next 5-7 years, not a big fan, but India can have their first space unicorn, and we'll all root for it, and hopefully we have many more going forward. So we see the very huge potential. Potential was never a problem. The money was the issue, but that is changing rapidly, and that was supported because of the change in the government and government policies. Prime Minister himself heads Department of Space, so he personally heads as a Prime Minister office, and then he heads the Department of Space, and then he heads another department, that is Department of Atomic Energy. And these two other departments are very critical for the new age sustainable development. So, and he personally is very passionate about the space. So he interacts regularly with the startups, spends some time whenever he get time, he talks to them, understand what are the challenges, if he can do something on those things. So that helps a lot to motivate.
It's very good to hear all of these, very dynamic developments. And I mean, speaking of the funding, and you yourselves, Manastu, you announced a $3 million pre-Series A round yesterday. And for full disclosure, the venture fund I'm involved in, E2MC, was one of the 3 funds leading that round. So with all of these exciting things going on in Indian space, what's next, do you think? What's the next big thing? Is it going to be sending Indian astronauts on an Indian vehicle to space? Or what could it be?
Yeah, for sure. That is exactly the next milestone for Indian space. Can we have Indian astronaut human into the space on Indian vehicle. That's the next target. Hopefully this year end or early next year. That's what we are targeting. Country is targeting. We are looking for India is also waiting once the Aditya L1 mission reaches Sun in next 3-4 months, and it start doing the hello orbit. So how can we get some early data and see if we can get some closer looks at Sun? So that will be a very interesting development. So a lot of interesting things are in pipeline for ISRO. There are more missions. NISAR mission is there, which is along with NASA. This is one of the probably the most expensive satellite for the Earth observation. So that is another next interesting milestone. It can it can unveil a lot of things that is happening on the Earth. So that will be our next major looking forward objective mission.
There's going to be continued inspiration for the kids. But it was so great to hear those anecdotes you were telling about your niece and so forth. I think that sort of foretells a great continued future for Indian space. And actually, I can see it myself. I mean, you may know that I have a few online space education courses out there. Mm-hmm. And I was just looking at the statistics yesterday, and the second biggest national group after the US for my courses is students from India. It's like 15% of all students. And that was very good to see. But Tushar, we're coming kind of towards the end here of this podcast. I mean, you could go on for hours talking about Indian space. But our traditional last question is always the same, which is about science fiction. Do you like science fiction? And if yes, what are some of your favorites?
Oh, of course. Why not science fiction? I mean, that's where everything starts. I think with the science fiction, every space company, CEO, engineer, somewhere or the other has that science fiction in the mind. Science fiction is maybe multi-planetary mission. That is definitely you can. I don't want to say science fiction because that becomes because we are working towards making it reality. So maybe we can go to say moon and then immediately to the Mars, and then we get some resources from some of the asteroids, say helium-3 or more of a platinum and all those things, and then bring back to the Earth, reduce some load on the Earth, and become, like the way we travel from one country to another country. Can we do that regularly for one planet to another planet with stops in between, like moon and other things? So if we can do that, that's definitely, and that too a very short, maybe in this lifetime. So I want to believe that as a more of a goal than science fiction.
Okay, so that's fair enough. So rather than consuming science fiction, you guys are actually working on the science fiction. But I guess sort of on the arts aspect, very interesting to see. I don't know the Bollywood, the Indian film industry that well, but maybe now with all of the excitement about space, it's going to be time for some Bollywood space-themed movies.
Absolutely. So we had supported some of the writers to some of the script to make it more authentic through the space side. There was one TV series regarding the space cyber attack, space satellite attack through signals colliding to satellites. So we helped them to make script more authentic, give the more real life to this thing. So hopefully if that comes out, that might be one of the good start for our Bollywood maybe.
And that's great, because then that's going to bring the space industry and what's going on in space to even more people in a different way. Tushar, thank you so much for spending the time today. Very interesting to hear about both Manastu and what's going on in Indian space in general. So again, thanks.
Thank you, Raphael. Thank you, whole team, and looking forward to meet you personally soon, hopefully very soon.
For sure.
Well, that's it for another nominal episode of the Space Business Podcast. If you like this podcast, please consider giving it a 5-star rating on your favorite podcast platform, such as iTunes. You can follow us on Twitter at podcast_space. Also consider supporting us at www.patreon.com/spacebusinesspodcast. If the podcast got you interested in learning more about the business opportunities in the space economy, check out my new online course on space entrepreneurship on udemy.com. The link is in the episode description. Lastly, if you have any feedback, including ideas for guests, and that may include yourself if you have an exciting space story to tell, or interested in being a sponsor, drop us an email at spacebusinesspodcast@gmail.com. I look forward to seeing you for the next episode.